Greetings friends. In this short video I want to show you how to use VassarStats in order to compute an ANOVA. As you recall from our class discussion, all an ANOVA is a series of t-tests. So basically an ANOVA is t-tests when you have three or more groups. And the way that you compute an ANOVA is to use this VassarStats screen here. On the left hand side you access it here under ANOVA and then under one-way ANOVA. And we'll say that you can use this for up to 5 samples. Here's the dialog box, which asks you to indicate how many samples you have, how many groups you have in your sample, and then you will enter the data the same way you did for the t-tests. In this case it's going to be an independent samples ANOVA, and number of groups is 3, and this is where we're going to put the data. I've already put some data together here, 3 different groups, group A, B, and C, and you will enter it the same way that you did for a t-test. You just copy and paste under group 1. Make sure the cursor is right after the last entry of that column. Copy and paste here, and then copy and paste in this column here. Again, these columns don't need to be the same, have the same number of numbers in the column in order for you to compare. Again, we already have selected independent samples, and now we hit calculate, and the calculations are performed for us. This will look very similar. The same kind of information is in these boxes as was in the other box that we saw for the t-tests. The only thing that's different is this post-test called Tucky. And what this does is it compares the groups to each other. So it will compare the mean of group 1 to group 2, the mean of group 2 to group 3, and the mean of group 1 to group 3. So those are the 3 possibilities that you have. And down here it shows you the results of those. Now we're looking for the same p-values. It has to be less than 0.05. So in this instance we have 2 of the groups are statistically significant different. The means of the groups are statistically significantly different. Group 1 and 3 and group 2 and 3 have p-values less than 0.05, in this case 0.01. We would say that, to write this out, we would say that the p-values for M1 and M2 are greater than 0.05 because that's the level of significance that we're testing for.